Welcome here to the Cambridge 2025 May-June paper 22 non-calculator. Let's jump into 2 hours of pure fun. Let's start with question 1, and we need to remember the difference between line symmetry and rotational symmetry. Line symmetry means if we draw a line like this, for example, then both sides need to be a mirror image. Now we draw a line here, we're going to have to shade that square and these two squares. So that's 3 squares, so that's not going to work. Same here. Line symmetry, we'll have to shave that square, we'll have to shave a lot. Okay, so I can only think of a diagonal line. If we draw a line like this, that will be a line of symmetry, because this shade will reflect, this square will reflect onto there, and then this square will reflect onto here, which means we need to shade this square here. Okay. There you go. There is another option. So that's correct, but just want to show you the other option is if we got a line of symmetry like this. Now this square is right through the middle, so this one have to reflect, have a mirror image over here. That's the other option. Okay, so the one or the other. They will both work. Okay, rotational symmetry is different though. Get my tracing paper. That is when we rotate the shape. So I'm just gonna trace the square. And there's a square here. I'm just gonna make a cross. And there's 2 squares here. Okay, so when it rotates, the shape needs to fit onto itself twice. Okay, at the moment, this is the closest we get. Okay, doesn't fit yet, but if we shade that square there, it will fit exactly. And then that will be 1, and we get back here, that will be 2. Okay, so let me show. We shade in this square here. So now that is also shaded. So rotational symmetry, we rotate it, goes around, it fits on 1, and back where we started, 2. Rotational symmetry, 2. 1 mark each. Moving on to question 2. This is a scale drawing, that's important, sometimes not to scale. This is a scale drawing, which means we can measure on here. 2 villages, P and Q. Scale is 1 centimeter is half a kilometer. So find the actual distance, and we need to measure the distance here. Now, sometimes when you photocopy or print exam papers, it can actually change this question. So it might not always be exactly the same. Just make sure you do the same. Mine goes up to there, so it's 87 millimeters. Okay, which will be 8.7 centimeters. Okay, so that distance, let's write it here, 8.7 centimeters. Okay, it tells us 1 centimeter is half a kilometer. So we just need to divide that by 2. So if we divide this by 2, we'll get the kilometers. Okay, 8.8 would be 4.4 kilometers, but that's half, so it's 4.35 kilometers. Okay. Now, as I said, yours might be different. Now, if I look at the mark scheme, actually shows that when I printed this paper, it shrank the shape a little bit, because the correct answer actually for the measurement is 8.8 to 9.2 centimeters. That will give you 1 mark. So actually I won't get a mark if my paper was printed correctly, but it wasn't, okay? And so your final answer needs to be between 4.4 minus just a little bit, not enough, to 4.6 kilometers for the second mark. Okay, if your paper is printed correctly. Part B, measure the bearing of village Q from village P. From is where we put our protractor. So always at the sake of where it's from. Okay, now remember for bearings, you must have the 0 always at the top. Put it on there correctly. Make sure it's center is exactly. Make sure it's not a little crooked. Exactly. And then we always go clockwise. From 0, so now we're using the outside numbers. Okay, and mine goes 90, 100, dead on 110. That's what I get. And the angle doesn't change when you photocopy or print this. Check. Okay, actually they do give some leniency here of 2 degrees. So anything from 108 to 112 degrees will get you the mark there. Moving on to question 3, we got some angles. 2 straight lines, 2 parallel lines. Yeah, every piece of information is important. The lines are straight and they are parallel. The moment you see parallel lines, you're going to look. Cheetah. Right, as I was saying just before the dog started barking, you're going to look for the alternate and corresponding angles. Okay, alternate of course is these Z angles. Don't call them Z angles if they ever ask. Or you look for the corresponding. Okay, so that's what we can start off with here. Alternate and corresponding angles. So, do we see any? Well, first of here I see here opposite angles, of course. It's always the same. We can do here 65. And then clearly jumps out at me. We got here a stretched out Z, which means this will be 45, and then here we got a pretty normal Z. So these are alternate angles as well. So this will be 65. Okay, there's the Z. Now we can look for F angles as well. Okay, you can see here's an upside down F, and we already have these 2 angles the same, the 45 and the 45. Let's look for many more F's. Well, just like I said here, there's another one. So we could have straight gone from 65 to there, 65. Okay. Other way you want to do it, you can see that there is here a triangle. So X will be angles in a triangle, or we got the straight line, angles on a straight line. Whichever way you perceive it, to find X, we need to do 180 minus 45 and 65. And of course 40 plus 60 is 100, 5 plus that is 110. So X would be 70. Okay, let's put that in there. So x is 70. Now again, we can do angles on a straight line to get y, but I think even quicker is look for this corresponding, there is an f here pointing the other way like this, which means 65, 65, or opposite. There's no third way to find that angle. There are many ways, meaning that is 65. Let's look at the mark scheme. Right. So this is why it's always important to show things on the graph, because if you don't get the marks below, they can come here, they can give you a mark for that. Right, should be red. Can you give you a mark for that, or a mark for that, or a mark for that? Any one of those counts one mark. If not, working out, that counts a mark. Okay, and then marks for the correct answers. Moving on to question 4. 1, 2, 3, 4, 5, 6, 7. She picks a card and then replaces it, which means she puts it back. That's very important. Find the probability that she picks an odd number. The odd numbers, of course, is 1, 3, 5, and 7. So there are 4 odd numbers and there are 7 cards. So 4 out of 7. Okay. 4 is or equivalence. You can write it as a decimal. I don't know what you want to do that. Just leave it as a fraction. Okay, or as a percentage. She does this 35 times, calculate the number of times I'm expected to pick an odd number. Remember, she puts it back. So each time the probability stays the same. Okay, so out of that 35 times, how many times is going to be an odd number? And all you need to do here is multiply. 4 over 7 times 35. Okay. Remember, we can put 35 over 1. Multiplying fractions, you multiply the top with the top, the bottom with the bottom. So we can do 4 over 4 times 35 and 7 times 1. And then simplify it. But better is simplify before you multiply, because we can divide the 7 and the 35 by 7. Divide the top and the bottom by the same number. Okay, which will make this 1. And we'll make this 5. A lot easier. 4 times 5 is 20. 1 times 1 is 1. So 20 out of the 35 would be odd numbers. It's kind of like also doing, you can just do equivalent fractions. Okay. If you pick ones, no, this is not going to work. I'm going to confuse you. That's the answer. Okay. All right. 20. Follow through from their answer. So if you take this answer, you multiply it by 35, you can get a follow-through mark. This is only 1 mark. Okay, 1 mark. 1 mark follow-through if you multiply that. Right. Question 5, transformations. First one is the translation. So what we need to do, take our tracing paper, trace the shape. Don't need to use a ruler for this one. Now the vector is 0. The top number tells us how to go left or right. 0 doesn't mean we don't go left or right. We should say where we are. -2. The bottom numbers tell us up or down. And since it's minus, of course, we go down. So simply 1, 2, down. And then we can see the shape will be there. And then you use a ruler to draw the new shape. Okay, and that's just 1 mark for the correct position. Easy. Next one, describe fully the transformation that goes T onto U. Okay, 3 marks. 3 marks. Okay, so the first mark is the type of translation. Okay, of course, there is enlargement. Enlargement. The shape changes size, so this is very unlikely to be an enlargement. What else do we have? We've got, of course, the translations. that we just do. The orientation doesn't change. So if this was a translation, it would be in the same orientation like that. So this is not a translation. Then we get rotations. Okay, that's quite looks like a rotation, doesn't it? Let's check if it is. Take a shape and we rotate. Well, I keep picking a random point here. Okay, that's obviously not it, but I see something else. Let's try to see what happens when you rotate it from here. Okay, something is wrong. See, even if I can get the rotation correct, can you see it's the wrong way around? It's upside, it's flipped. So if it was a rotation, it would have been, wouldn't have flipped. It would be like this, or like this, or maybe like that. But where are we going to have to rotate it from to get it like that? Something strange is going on. So if it's not a rotation, then what can it be? It can be a reflection. And what happens with a reflection? We get a mirror image. It kind of flips over. Does it flip over? Doesn't seem to flip over either. Must be then a rotation. Let's try rotation again. Maybe if we don't rotate it from here, it didn't work from here. Let's try from here. Oh my goodness. What? There, all of a sudden it jumped into space. So it was a rotation after all, and not a reflection. Just need to find the center. Okay. There is a way to find the center. I'll show you now. But let's just finish the question first. So that definitely is a rotation. Okay. You have to say which one it is. So rotation. You write that. You get your first mark. So we need 2 more things to make up the 3 marks. Okay. And the next thing we need to write is, of course, the direction. Okay, if you look at the watch in your room, your wrist, it always, the arms of the watch always goes this way around, so that would be clockwise, but we're going the other way around. So it's anti-clockwise. Okay, and what is the angle there? Quarter turn, 90 degrees. Okay, you can also see if you draw like a line going to the center, and then that same corner, right there, can you see that makes a 90-degree angle? So 90 degrees. So anti-clockwise and 90 degrees, that gives you your second mark. And the last mark, we need to write center. There's the center, so along the corridor is 2. Up the stairs is 2. Okay. I said there's a way to find this. It's the center. It's a bit of a, it takes time. But if you struggle, but you can always do this. If you connect the sides, okay, and then you take the middle of the line, which is right there, and you draw perpendicular. Okay, you might want to use a set square or your compass, perpendicular bisector. So I've connected that, halved it, and I draw a 90-degree angle, right? And then we do the same. Let's do the same for this acute angle here. The midpoint of that line will be there. And then if you draw a perpendicular bisector again, this is like constructions. See what's happening? And let's do the last angle here. Connect those two. Where's the middle of this line? Well, it would be there. It's the same space, the same line. It would be the same line here. Okay, either way, you see? Perpendicular bisector of the lines you connect, they always converge on the center. Just now if you struggle. It's quicker just to do trial and error, in my opinion. But there you go. get full marks. Next question. Okay, moving on to question 6, simply solving an equation. Remember to keep things lined up. We want to have the x alone at the end. So we now need to do the same on both sides. So we're going to get rid of the 7. We're going to subtract 7 from both sides. Or that's one way of doing it. Or you move the 7 to the other side. And it becomes either way. 39 minus 7 is 32. And then to get rid of the 8, divide 8 on both sides. That will give us the x. 32 divided by 8 is 4. If you got the time, do a quick check. So 8, we said x is 4, so we put the 4 for the x's. Plus 7. 8 times 4 is 32, plus 7 is 39. And we know it's correct. Okay, check the mark scheme quickly. For subtracting that 7, we get a mark. Okay, show working out in case you make a mistake. Same with the next one, question B. There are 2 ways to solve this one. I'll quickly do both. Okay, first thing we can do, we can divide the 2 on both sides. That will give us 5y minus 1 equals 12. Then we add 1, which gives us 5y equals 13. And then we divide the 5, which gives us 13 over 5. Okay. Nobody said we have to write it as a decimal, a fraction, mixed fraction, improper fraction. So 13 over 5 is fine. Or I guess you could write 2 and 3/5 or 2.6. Okay, let me show you the other way of doing this. So there is another way. The other way is expanding the brackets and then solving it. So sometimes this works better. Okay, 2 times 5y is 10y. 2 times minus 1 is minus 2. That stays the same. Then I'm going to add 2 to both sides, so that gives us 10y equals 26. And then divide by 10, which gives us 26 over 10, which you can change straight to 2.6. We simplified, you get 13 over 5. They're all correct. Okay, so they say 2.6 or 13 over 5 or equivalent. So, yes, to get your marks here, you can write any one of these. So 2 and 3/5 is equivalent, right? Marks given here. For the first correct step, is either dividing the 2 or expanding the brackets. Okay, so basically you'll get a mark here for dividing 2 or for correct expanding the brackets, then another mark for isolating the y, and then a mark for the correct answer. So you're working out. That is the moral of the story. All right, question 7. These are 4 term sequences. Immediately we try to see what's the term-to-term rule. And we see that here we are subtracting 3. To find the next term in the sequence, 2 minus 3 will be minus 1. Okay. The nth term. Okay. The nth term is not n minus 3. That is the biggest mistake. Don't do that. Okay, the minus 3 is like the minus 3 times table. Okay, the minus 3 times table goes minus 3, then you so 1 times minus 3 is minus 3, 2 times minus 3 is minus 6, 3 times minus 3 is minus 9. Because in the minus 3 times table, you subtract 3 every time. Okay, it goes to minus 12, it goes to minus 14. That's why the nth term rule will start with minus 3 times n, or just minus 3n. Okay, because that's the minus 3 times table. Right, what's the difference here between the minus 3 times table? Each one that you can see, to get from 2 to minus 10, you have to subtract. What do you have to subtract? 13? Something's wrong. 14. You should have to subtract 14. Now, this is the mistake. the next to the minus 3 times table isn't minus 14, is minus 15. So you subtract 14. See? 5 minus 14 is minus 9. 8 minus 14 is minus 6. 11 minus 14. Or, well, it's the other way around. We have to add. Minus 3 plus 14 is 11. Minus 6 plus 14 is 8. Minus 9 plus 14 is 5. Minus 12 plus 14 is 2. And minus 15 plus 3 every time. And then we'll continue like that. But even easier and quicker, just continue the sequence that way. We have to add 3. Minus 1, 2. Plus 3 is 5. Plus 3 is 8. Plus 3 is 11. Plus 3 is 14. That also gives us minus 4. That's the shortcut. So that means at the end here, we need to put a plus 14. And then in the mark scheme, you'll have to see, right, they give 1 mark for minus 3n and 1 mark for positive 14. Or equivalent, so I wrote mine the other way around, doesn't matter. 14 minus 3n and minus 3n plus 14 is the same thing. 1 mark for each. Again, nobody marks in blue. Okay, and then minus 1 was correct as well. Question 8. Again, there are different ways of doing this. We can write down all the factors of 36. It's all the numbers that goes into 36, which is 1. And they always come in pairs. And 36, because 1 times 36 is 36. 2 and 18. 2 times 18 is 36. 3 and 12. 3 times 12 is 36. 4 and 9. 4 times 9 is 36. 5 goes in the 36 table. No. 6. Yes. 6 and 6. Well, I want to put 6 twice, but 6 times 6 is 36. And then 7 is in the 36. 6 times 12. 8 isn't. 9 is. We already have it. There are all the factors of 36. 54. Again, 1 times 54. 2 times 27. 3, yes, 3 goes in there because 5 plus 4 is 9. 9 is in the 3 times table, so 54 is in the 3 times table. What would that be? 18. 18, yes. So 3 times 18. 4 goes in the 54 times table. Like 12 times 4 is 48. 52. So no. 5, no, not in the 54, isn't the 5 is not a factor. 6, yes, of course. 6 times 9. 7, no, because 7 times 7 is 49, and then it's 56. 8, 7 times 8 is 56. 9, yeah, we already got the 9. Oh, there's all the factors of 54. Sorry for that big space. Then we just need to see what are the common factors. So we got the factors. Now we do the common. Common is they have 1 in common. They got 2 in common. They got 3 in common. They got 6 in common. They got 9 in common. 12. Now you got 18 in common. And there we go. That is the highest. The highest common factor, highest one, the biggest one, 18. Okay, that's one way of doing it. One way. The other one is using, because it's very big numbers, you might want to use the prime factors. That's the one where you got, well, there's again different ways of doing this, but you got 36. This is the fishbone method. 2 is the first prime number, and it goes into 36. 36 divided by 2 is 18. We can do another 2. That gives us 9. Now we go into 2. The next prime number is 3. 9 divided by 3 is 3. And another 3 gives us 1. So that means 36. Its prime factors is 2 times 2 times 3 times 3. Okay, those are the prime factors. Let's do that for 54. There's got another way of doing prime factors. That's the prime factor tree. Again, we go 2. 2 times 27 is 54. Then we do 3. 3 times 9 is 27. And we break that down into 3 and 3. So 54 has the prime factors 2 times 3 times 3 times 3. Okay, so get the highest common factors. we just take all the ones they have in common. There's a 2, the more, and then we can do the 3 and 2. They work 2 3s in common. Okay, so that means the highest common factor will be 2 times 3. 2 times 3 is 6, times 3, 18. Same way. 2 ways. Do the same question. 18, there we go. Right, so let's do marks again. So you get a mark if you've done my first step. You identified these common factors, you get a mark, red, and then a mark for the answer. Or if you've done a correct factor tree of either, and then you get the second mark for the correct answer. Right, for question 9, I've moved on to here where I've got a Cartesian plane. And the first thing we see is A is the point 3 minus 1. So if you struggle with this question, it's always good to draw yourself a little diagram in the exam. So this is point A, 3 minus 1. Now AB is a vector. Remember, in a vector, the top number tells you how to go left or right, how many spaces. Of course, to the right is positive, to the left is negative. And the bottom number tells you how much to go up or down. Positive, you go up, negative and down. So here means, the 2 means we go 2 spaces to the right, and the minus 4 means we go 4 spaces down. Okay, so let's do that. So we go 1, 2, and 1, 2, 3, 4. Okay. And that is where our new point would be. There. Okay. Right, so that will be point B. Right, so now we can see exactly what that means. Of course, the distance between them, that would be the vector AB. So we can draw a line with an arrow. Right, that's AB. That's the vector AB. Right. So then it says AC. Where's C? We don't know where is C. That's what we need to find. Is twice AB. Okay, that's not hard. So if AB is 2 minus 4, then AC will be twice that, which means that would be 2 times 2 is 4, 2 times minus 4 is minus 8. Okay, so that means instead of going 2 spaces to the left and 4 spaces down, we go 4 spaces to the right and 8 spaces down. Okay, another way to do this without the sketch is to recognize that because the top one tells us left or right, just like the x-axis goes left or right, we need to take point A and we need to add 2. Well, point A is 3 minus 1. And so to get point B, we need to add the 2. It's not a minus. I'm not doing well today, am I? To get point B, we need to add the 2 to the 3, which gives us 5. Which here you can see, point B is 5. And subtract the 4, which is minus 5. So yeah, 5 minus 5, you can see that's B. Now 2 AB, AC is twice AB, so we just need to do this twice. Instead of going 1, 2, we go 1, 2, 3, 4. And instead of going 1, 2, 3, 4, we go 1, 2, 3, 4, 5, 6, 7, 8. Okay, we're just doubling, right? Doubling that vector, because that's what it is. AC is twice AB. So the answer is 7 minus 9. Or if you do it here, we just need to add another 2 or add a 4 to the 3, so it gives us 7, 3, 5, 7, and subtract another 4, or subtract 8, which gives us minus 9. As you can see over here, C is 7 minus 9. Okay, there's two ways of explaining it. Let's check the mark scheme. 7 minus 9, and 1 mark for each. Or you don't have got that 1 mark if you see 4 minus 8. So in short, you get 1 mark here for each vector. If you don't have, if you are completely wrong, you get 1 mark for 4 minus 8. Okay, that's how you can get the marks. Okay. Right, then let's just clear the clutter a little bit. Okay, we're going to go back to just AB. Right, it tells us the length of AB is K root 5. So something times root 5. How do we find the length of KB? Alright, yeah, well, as you can see, we go like this. We know that that was 2 because we moved 2 spaces to the right. And this here, going down, just the length. I know we're going down 4, but the length of that line is 4. Okay, we have there a right triangle, so we just need to do Pythagoras to get AB. So, yeah, AB squared, which is AB squared is K root 5. Oh, I need to write bigger and nicer. So basically, because this is the hypotenuse, remember Pythagoras, square root of the hypotenuse is the 2 other sides squared together. Okay. Alright. Remember, it's always positive. If you do want to do minus 4 squared, it's going to give you the same as 4 squared. So that you can put in. You basically take the vector, you square both for Pythagoras. Okay. So which will be the best way to solve this? Right. We can work this out. 2 squared is 4 plus 16 is 20. Well, there's 2 ways. So this will be 20. If we square this, we need to square both the k, so that'll give us k squared, and the 5, right? So the square root of 5 squared. Square the square root, what you get? It just cancels each other out. So we can put that 5 in front. Or the back, doesn't matter. Let's leave it there. So the square root 5 squared is 5. And then divide the 5, of course. So 20 divided by 5 is 4. So if k squared equals 4, k would be the square root of 4, k would be 2. That's one way. The other way would be to move the square root across. Just to show you there are other ways of doing this. Okay, we could have done k square root 5 is 20, the square root of 20. And then divide square root 20 divided by square root 5. And remember, that is the same as square root 20 over 5, which is square root of 4, which is 2. Okay, same thing. Either way, mark scheme 2 is the answer. And see that minus I was talking about, you don't need it, but you get a mark for showing Pythagoras. Bam, mark for the answer. Okay, we're making good progress, but although I don't have much space here. Right, P is the point on AB. Right, going on to question C, I've enlarged the graph a bit and cleared up the clutter so just we can see things clearly. Change the color here. Okay, so it's telling us AP is in a ratio of 1 to 3 to PB, right? So the A and the B still refers to the A and the B, those 2 points which we had, okay, which was 3 minus 1 and 5 minus 5. Okay, the ratio is 1 to 3. Okay, so if we take that ratio, we add it together, that gives us 4. That means we need to divide the length of this line into 4 parts. Okay, so let's do that. That would be 1, that would be exactly halfway, and halfway of that would be there, halfway of that would be there. Those are 4 parts, and the ratio is 1 to 3. So it means for 1 part we move here, we got 3 parts there. So P is this point here. Okay, give us the ratio of 1 to 3. So the coordinates of P would be, if we go up, 3.5 and minus 2. Okay. Now it says find the position vector. This means the position is where you start from the origin, the beginning. The origin here, of course, is there. So the position vector is, how do we get from here to there? Okay, this is the position vector of P. We'll call it OP. O being the center, the 0, the origin. Okay, and to get there, of course, we need to do what? We need to move 1, 2, 3.5, because that's there. 3.5 to the right, and then 1, 2 down, which is minus 2. Straightforward. The position vector is 3.5 and minus 2. Okay, best thing to do these questions is draw yourself a little diagram. Okay, maybe you don't have the Cartesian plane, but you can always draw it and envision it. Okay, so that's the answer. 3.5 minus 2, or equivalent, I guess 3.5 as a fraction, or 3.5. Okay, and then 1 mark for each. 1 mark here. 1 mark for each. 1 mark for this. 1 mark for that. Okay. Let's move on to question 10. Okay. We got a sector of a circle, or in short, a pizza slice. The length of the arc is n pi. Always read all this. See, that will show you, okay? That's important. N pi, whatever that means. N pi. Find your value, okay? So we're looking at the length of an arc. And we need to know the formula for the length of an arc, because they don't give it to us on the formula sheet. So you need to remember this. Okay. The length of an arc, or in short, arc length, is, well, the arc is part of the circumference of a circle. The formula for circumference is 2 pi r. Or pi d, of course. But since we have here the center of a circle to the circumference, remember this could be a whole circle. We have the radius, so it's better to use this one. Okay, so that would be 2 pi r. And that would be the whole circle, but here we have a fraction of a circle. The sector, the arc length is just a fraction of the whole circle. Okay, and that is 45 degrees out of, what would be a whole circle? 360. Well, I'm going ahead of myself now. The formula is, okay, usually they give it this, which refers to the center of the circle, the angle at the center, the 45. That's the theta sign, which is 45 degrees over 360. So memorize this formula. You need to, and then we do 2 pi r. Okay, now we need to find n. Where's n? There's n. N is there or there. Okay, that is, so that means that is the arc length, n pi. So that is equal to n pi. Now we just need to work a bit here and try to simplify things. Okay, let's see what we can do. Can we simplify 45 over 360? Yes. 45 is such a well-known angle, if I can say this. Okay, remember, if you got a circle, you cut it in half. Now you got 180 degrees. Cut it in half, you got 90. All the angles are 90, and you cut that in half. Now you got angles that's all 45 all around. So that means 1, 2, 3, 4, 5, 6, 7, 8. That is 1/8 of a circle. Okay. Or you can do 40. You just simplify the fraction. Yeah. 45 divided by 360. 45 divided by 45 is 1. 360 divided by 45 is 1/8. If you take 360, you half it, you get 180. You half it, you get 90. You half it, you get 8. Anyway, okay, one thing I've left out, we've got the radius there. Well, we have it, that is 18. So we can substitute the R for, well, let's do it over here, for 18. Okay, and then of course 2 times 18 will give us 36. So that will give us 36 pi. Okay, so what's 1/8 times 36? What is 1/8 times, let's put the 36 over 1. We can simplify this, we can divide both by 4. So that will give us, this was 2, and 3 is 9. So 1 times 9 is 9, 2s, or 4.5. So 1/8 of 36 is 4.5 pi, and pi. Now we just need to get rid of the pi. We divide the pi on both sides, and that will cancel. Pi divided by pi is nothing, so that gives us n equals 4.5. Only 2 marks for that, these stingy people. Okay, 9/2 or equivalent, so you can write 9/2 or 4.5, 4.5, and 1 mark there, you see, for writing down the formula of the arc length, but with the numbers substituted. So this is where you get your mark, and then 4.5 written in any form gives you your final mark. Question 11, standard form. Okay, remember standard form, the first number is always from 1 to 9. Okay, so you move the decimal point 1, 2, 3 spaces to just after 7, which gives us 7.08 times 10. And because it's a small number, we move the 3 spaces to the power of -3. Okay, correct answer only. So you cannot write anything else. Has to be that. Remember, the decimal point is not after the first significant figure, the first digit is not in standard form. Okay, so that's the only answer that's correct. There's no other correct answers here. Correct answer only. Next one, we need to work out adding them together, right? Okay. I'm going to do this the long way, but you don't have to do it the long way. We know that 3.8 times 10 to the power of 22 is 38. We need to move that decimal point 22 spaces. Okay, so the first space is the 8 and then another 21. Okay, so let's do 21 zeros. 1, 2, 3, 4, 5, 6. That's 21 zeros. 7 sets of 3. Okay. Then the next one, we do the same. Move it there. Then we have 22 zeros. Okay, so it means we 1 here and then another 21 zeros. And then we have the 38. What they want you to just recognize that this 3.8 and that 3.8 is not the same 3.8. Okay? If you look at the place values, this is how they line up. And now we can add them together. Okay, so add up all the zeros. So again, we'll have 21 zeros. 0 plus 0 is 0. 21 times. That's a 0. Okay, then 8 plus 0 is 8. 3 plus 8 is 11. Carry the 1 for 480. I don't know, quintillion? Who knows? Okay, Pretty much the depth of the United States at the moment, I think. But anyway, so now put it in standard form. The decimal point is over here. We need to put it there again to make it 4.18. So how many spaces are we moving it? Okay, so 21, 23, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. You didn't have to count that. You knew that, right? 21, 22, 23, bam, decimal point over there. So times 10 to the power of 23. 4.18, 10 to the power of 23. Correct answer only. Alright, they show a lot of things here, alright? Basically, if they see the digits 418, without decimal point, 1 mark. And correct, you have to have this full marks, 2 marks. Question 12 is a circle theorem. What you need to recognize here by reading, PQR is on the circumference of the circle. QR is the diameter, that's very important. So recognize here that of all the circle theorems we have this one, which is the angle at the center. Well, same angle in a semicircle, not the angle at the center. Angle in a semicircle, meaning if you got a diameter and 2 lines that subtend from that, you have 90 degrees. Always see it looks, it's always 19. This is fun. Okay. Can we change anything? Yes. Oh, we can change that. See, it stays 90 degrees. Yeah. So angle in a semicircle. You need to know those words as well. Angle in a semicircle is always 90 degrees. So that means we know this is 90. Okay. So they want to know PRQ is here. They want to know that angle. So this will be a straightforward 180 minus the 90 and the 74. So that will be like 90 minus 74 is 16. Okay, now this is not the geometrical reason. This is the calculation. So this doesn't count as the reason, my calculation. Calculation is angle at the angle in the semicircle, because, okay, so let's write this clearly. RPQ is an angle in a semicircle. Well, that's not the only one we used. We also used angles in a triangle as 180. Now, if you're unsure, do I write that? Yes, let's write it. So let's write and angles in a triangle equals 180. So those are the two geometrical reasons I've used. There's only 2 marks, so I don't think they want both. Let's see what the mark scheme says. Okay, so B1 for 16, or angle in a semicircle. Okay, so yes. Right. To get full marks, you need to have both. Okay. So 2 marks means 16 and that and that. Okay, so you need to have both those reasons. Okay, not just one. You only got one, you got 1 mark. If you don't have angles in a triangle, it's 180. Then you only get 1 mark for these. Basically, you have to have all 3. If you've got left one thing out there, you get 2 marks. So if you're not sure how much to write as much as possible. Right. 100 students solve a puzzle. Who got these 100 students in one room to solve a puzzle and timed them? The table shows information about the time taken by each student to solve the puzzle. So 30 students took between 20 and 40 seconds. Okay, it's a second. It's not too tough a puzzle. 40 students took between 40 and 60. and 30. So all of them solved the puzzle in less than 100 seconds, but nobody did it quicker than 20 seconds. Okay, what a puzzle. Wonder, I want to see the puzzle. Usually this is a calculator question. Okay, and this is a non-calculated paper. Right, so to work out the mean of something, we need to add up everything. So we need to add up the time every single student took to solve the puzzle, and then divide it by how many students there are. Okay, which is 100 until the beginning. Now, we don't know exactly how long each student took. We know these 30 students took between 20 and 40. This is why this is an estimate of the mean. Okay, because we're going to take the midpoint here. We're going to say we don't know these 30 students. They took between 20 and 40 seconds to solve the puzzle. We don't know exactly, so we're just going to guess, estimate that on average they must have taken 30 seconds. These 40 students must have taken 50 seconds, and these 30 must have taken 80 seconds, since 80 is halfway between 60 and 80. Okay, so we need to add up all their time. So we say there were 30 students. There were these 30 students here, and on average they took 30 seconds. Okay, so that would be 900 seconds altogether if one had to do it after the other. Then we need to add these 40 students here, who on average took 50 seconds. Okay, so then 4 times 5 is 20. Add the 2 zeros, they took 2000 seconds. Okay, and the last one is these 30 students. They on average took 80 seconds, we estimate. So 3 times 8 is 24, and then there's 2 zeros. So we just need to add that up. Okay, well, if you're not good in your head with this, just make sure you do it right. Okay, don't take any chances. This will be 0, 0, 4 plus 9 is 13, so 5,300 seconds. Okay, 5,300 seconds. It will take them to finish the puzzle if each 100 has to do it one after the other. That's all the time they took together. Okay, and then mean is we take that 5,300 and we divide it by how many there is. That's 100. So we just take away 2 seconds, and our estimate it's 53 seconds per student. Where would 53 be? It would be here in the middle, kind of. Right? So that's a good, reasonable answer. Let's check at the mark scheme. 53. Alright, one correct midpoint, seen or implied, for adding it together, dividing it by 100. So, working out here is important, in case you make a mistake. Okay, they give you 1 mark for the correct midpoints. They give you 1 mark for adding them together. They give you 1 mark for dividing your answer by 100, and then for 53, final answer. Right, moving on to question 13a, part 2, histogram. Okay, and what we need to remember the histogram is that the area of this bar, which is just a rectangle, okay, which has the frequency density as its height or length, and this is the class width. The area is the frequency. Guys, remember, frequency, which just means the amount of students in this case, there it is the area of the bar, which is the class width, which is this, the class width. So how wide the class is, 20 to 40, this is 20. This is also 20 from 40 to 60, and this is 40, times the frequency density. I'm too lazy to write that out, for FD, which is the y-axis over there. Okay. So what we actually want to know here to draw the bars is we don't know the frequency density, so we need to divide that over there. Okay. So frequency density, the y-axis, is the frequency divided by the class width. Right, so for the first one, the first bar, it would be, the frequency would be, let's make it frequency density 1, would be the frequency is 30, divided by the class width, which is 20, which is 1.5. 30 over 20 is 3 over 2, 3 divided by 2 is half 1, which we can see here, that is 1.5. Okay, so we're going to have 3 bars, so we need to do the second one. Frequency, the second one will be 40 divided by 20, which of course is 2. And the third one will be 30 divided by 40, which is 3/4, 0.75. Okay, so take out your pencil. My pencil is always green. Take out your ruler and let's draw those bars. There we go. If it's clear, don't shut it in, don't waste your time. You've done it, show you're working out. Let's look at the mark scheme. Heights 2 and 0.71. Okay. Basically, it's 2 marks, 1 for each. If you got this wrong, but they saw the right calculation, you can get 1 mark there. So again, show you're working out. Moving on to question B. Now they let the adults do the puzzle. I don't know if you noticed, but 12 adults got it less than 40. 30, so the adults is a bit slower. Look, some of them even took as much as up to maybe possibly 120 seconds where all the students were less than 100. Okay, very accurate here. The adults is a bit slower, that's true. Okay, draw a cumulative frequency table. Okay, now very important. Frequency diagrams. Where we used before the midpoint, remember here we used the midpoint for question A. Question B, for histograms we use the class width. So first we use the midpoint of the class, then we use the class width. Cumulative frequency, we use just the upper end, the 20, the 40, the 60, the 80, the 100, the 120. And what they've done is they've added up the values. Okay, so nobody did it in less than 20 seconds. 12 people did it in 40 seconds. 36 people did it in less than 60 seconds. That means 24 people did it between 40 and 60 seconds. Does it make sense? So 60 people less than 80. So that's 24 people between 60 and 80 seconds. So they just added up the frequency as you go along. That's why it has to add up to 80, because there's 80 people. All of them did it less than 120 seconds. Anyway, let's just plot the points. First is 0. Okay. So cumulative frequency 0, time is 20. And this is where they start the graph. Okay. So that would be the first point. Then 12 and 40. Okay. 40 is over here. And 12, look, each one square counts, one value. There we go. Next, 36 and 60. So 60, this would be 35, 36, 36, there we go. 60 and 80. Oh, wait. 36 and 60, 60 and 80, yes, 60 and 80. So 80 is over here. Time is 80. Cumulative frequency is 60. 74 and 100. So this is 100, 71, 72, 73, 74. And 120 and 80. Okay, again, use your pencil. And without a ruler this time, smooth curve. No ruler needed. Okay. It's got that distinctive shape all cumulative frequency graphs have. Okay, 3 easy points here. Remember to use the upper values. Let's look at the questions. Use your current frequency code to find an estimate for the median. The median, the middle of course, so middle of 80 people, okay, is 40. So the median will be at 40. So we need to use the graph. So we should go across. It's better to use a ruler here, but I don't have a ruler at the moment available. So you meet the graph and then you go down. Show this on your graph, then you're more likely. Okay, now look closely at the axis here. There is 5 squares between 60 and 70, so that means each square counts for 2. So that will be 62 seconds. And then the quartiles is just if you half a half, you get a quarter. Yeah? Half a pizza, you got middle of the pizza, half the pizza. You half that again, you got a quarter. So we just take the bottom quarter. Half of 40 is 20. This will be the lower quartile. And of course here at half between 40 and 80 is 60. That will be the upper quartile. But what they're asking for is the lower quartile now. So you go across, go down. And that will be 42, 44, 46 seconds. Okay, they got some space here, 62 to 64 seconds. So my 62 is at the bottom value there, so you can have 62, 63 or 64. And then 46 to 48, again I'm at the lower edge here, you can have 47 or 48. Okay, it's all about accuracy, so I'm lenient. Let's move on to question 14. Write 0.25 as a fraction. Okay, there is a specific way to do this, and that is using algebra. You set the value equal to x. And remember, 0.25 with a dot on top of the 5 mean there is an infinite amount, recurring infinite amount of 5s. Okay. Now there are different ways to do this. You can times it by 10, times it by 100. I've got my own way of doing this. I like to, if there's one number recurring, I like to multiply it by 10. 2 numbers, 100, 3 numbers. Okay, so if we multiply this by 10, it will give us 10x on both sides, of course. And this all shaves one space to the left, so it's 2.555. Okay. Then we write the first equation just below the second equation, and make sure to line up the line up everything. The x's, the equals, the decimal points, and that will show you why the next step works. When we subtract this, we have 5 minus 5 is nothing, 5 minus 5 is nothing, 5 minus 5. 5 up to infinity is nothing, so that will eliminate all the infinite 5s. And it's wonderful to eliminate infinity, because then we can work with just numbers we understand better. So 5 minus 2 is 3, decimal point 2 minus 0 is 2, and 10x minus 1x gives us 9x. So of course to get x then, we just divide the 9 on the other side, so that gives us 2.3 over 9. There you go, you got it as a fraction. Problem is, we don't mix decimals and fractions because there are an infinite amount of fractions we can write. So if a fraction in its simplest form doesn't involve any decimals. But that's easy to fix. course, with equivalent fractions, if you multiply the top and the bottom number by the same number, we still have the same fraction. Okay, equivalent fraction. So we just move the decimal point one space to the left, so that gives us 23 over 90. Okay, just you know, 23 is a prime number. It doesn't have any factors left, 1 and 23, and I doubt that 23 is a factor of 90, so that would be the answer in its simplest form. Let's look at the mark scheme. It says or equivalent, so it doesn't have to be in its simplest. Okay. They've multiplied both by 100. That also works. So that or equivalent means what I've got. There is other ways of doing this as well. I'm not going to go through them all. Basically, showing the correct knowledge of the steps to working out and the final answer. It gives you full marks. Question 15. It shows us this graph. Okay. Y equals 2 over x minus 1. It's a reciprocal graph where the x is a denominator, where we divide with x. Because then this thing happens where we find the asymptotes. Well, the first question, is it right according to the point where the graph crosses the x-axis? There it is, over there. Of course, the x value is 2, and on the x-axis, the y is always 0, so 2, 0. That's straightforward. Okay, nothing else, 1 mark. Right. Write down the equation of each asymptote. What is this asymptote? Well, that is a line that you always approach but never crosses. So if you look here, I've put this into the decimal calculator. There's the graph. And if you look at this line, it gets closer and closer to the y-axis, but it never crosses. See, it looks like it's gonna touch it, but we zoom in. Bam, see, it's getting closer and closer and closer and closer. Let's zoom out a bit. Zoom out a lot. Let's go up to, let's say, I don't know, man, 20,000. Okay. Alright, we can go like this on forever because the graph continues forever. Okay, well, let's just zoom in. Where was it? I lost the line. There it is. So close, it's so close. So we have to zoom in, zoom in, zoom in. Oh, there we see. It's getting so close. What is this distance? 0.0001. So we will get infinitely close, but never touch it. Yeah, it's like the ant walking towards the wall, halving the distance every time, every second, but it will never reach the wall. Okay, that's what we got with the asymptote. Okay. Always approaching but never reaching that line. Right, so how can we reset this? Okay, so look what happens when I take the minus 1 away. It shifts, right? And then we got the x and the y-axis as asymptotes. At the moment we put, let's put something else in here. Let's put a plus. So plus 2, it shifts the asymptote, it shifted up. And now 2 is the asymptote. If I put a 1, now 1, y equals 1 would be the asymptote. Now the x-axis was the asymptote with the minus 1, now it's shifted down. Okay, so from that we can see that on here, so you can see that one asymptote is the y-axis. The equation of the y-axis is of course x equals 0, which is the y-axis. Why is that? Because if I take this and I put a 0 where the x is, what do I get? What is 2 divided by 0? Okay, I know this is a non-calculated paper, but if I show you 2 divided by 0, anything divided by 0 is a math error. So you can't check that in the exam, you just need to remember it. So that means x cannot be 0, because that would be impossible. That's why that's an asymptote. Okay. And then as you can see, the other one, asymptote here is minus 1. Okay. That will be the other asymptote. Y equals minus 1. Okay, why is that? Because if we make y minus 1, then if we add 1 to both sides, we get 0 equals 2 over x. We multiply the x there, anything times 0. Yeah, we have to multiply both sides by x to get rid of that x. So then we get 0 equals 2. Of course, that is impossible. 0 cannot equal 2. That would be nonsensical. It's impossible. So that's why y cannot be minus 1. That's why that's the other asymptote. So x equals 0, y. Be 1 for each. Oh, they didn't say you can write the y-axis. Okay, that's a strange one. I wonder if you can. It doesn't say so on the mark scheme. Well, they said the equation. The y-axis is not an equation. So yes, you can't write the y-axis. You have to write x equals 0. Okay, by drawing a suitable straight line on the grid, solve. Oh my goodness. This is one of the harder ones. All right, let's see. We have to solve this. What line are we talking? Well, we got this equation. Y equals 2 over x equals 1. Minus 1. Okay? And then they gave us this equation, which is 2 over x minus 1 equals 0. Okay. Now the question we need to ask ourselves, how do I get from this equation, which I have the graph of, to this one, which I don't have the graph of? Okay, this is like a combination of two. So what has come here? So they have another x. So if I want to go from here to here, or shall we do it the other way? If I want to go from here to there, I'm going to have to add an x. Alright, and there is no y here, so I'm going to have to add a y on the other side. Okay, so if I've got 2x minus x plus x, that will cancel, so then I'll have 2 over x minus 1, and 0 plus y is y. So now I have, see, if I add this to that, I have the original equation. And this is what we need to draw, the x and the y. So we need to draw the graph of x equals y. And that's easy to draw. Okay. If you have a ruler. I don't have a ruler here at the moment. But x equal y is just always where x and y is equal. So that would be at 0, 0, because x and y is 0. At 1, 1, because x is 1, y is 1. X is 2, y is 2. X is 3, y is 3. X is 4, y is 4. X is 5. It's a diagonal line. X is minus 1, y is minus 1. X is minus 2. This is the line we need to draw. Okay. So please use a ruler, draw a line. Okay, and where do these two graphs cross? Okay, let me just say this is the line y equals x. Where do they cross? Over here at the point 1, 1, and at the point minus 2, minus 2. Alright, so what do they want? They want the x value. So here, of course, the x value is 1, and the x value is minus 2. X equals 1, x equals minus 2. We can check if this is correct. Okay, let's see. If x is 1, let's put it there. So 2 over 1 minus 1 minus 1. Does that equal 0? 2 minus 1, 2 divided by 1 is 2, and 2 minus 1 is 1, minus 1, yes, so that is correct. And if we put a minus 2, minus 2, minus 1, is that correct? 2 divided by minus 2, 2 divided by 2 is 1, so it's minus 1. 2 minuses makes a plus. Yes, that is correct as well. See, those are correct values. Let's check what the mark scheme says. X equals 0. Y equals minus 1, 2 marks. Oh, here, sorry. Y equals x. Y equals x. So you get 1 mark for the graph. And then 1 mark for each correct answer. I don't think the order is important. On to question 16. Right, let's read all the information very carefully. The diagram shows a solid. Okay, it's not hollow. Made of joining a hemisphere, half a sphere, to a cylinder. All right. The radius above is 6 centimeter, the cylinder and the sphere. The height of the cylinder is 5 centimeters. Find the total surface area. So for this, we're going to go to our formula sheet. We are working out surface area. And here we got some formulas. Okay, we got the curved surface area of a cylinder and the curved surface area of a cone. No, surface area of a sphere. Let's start with a sphere. Okay. So, surface area of a sphere is A equals 4 pi r squared. So let's write that down. Okay. Surface area of a sphere is, what was it? 4 pi r squared. Okay. Do pay attention to detail because this is not a sphere, it's a hemisphere. And what is a hemisphere? Well, that is half a sphere. So we're going to have to divide this by 2. Okay. That will cover for us this part, yeah? But not the circle, not the base of the hemisphere. Because that is not the surface area. That is inside the solids, okay? So we're not going to do this. So that would be the hemisphere. So let's get that first, okay? So we can simplify this. 4 pi r squared divided by 2, you just do 4 divided by 2 gives us 2 pi r. And the radius, of course, they told us, of both is 6. So that is 6 square. That will give us 2 pi. 6 square is 36, not 12. 2 times 36, 72 pi. Okay, this is going well. Then we need to do the surface area of the cylinder. Okay, so we go here. Oh, this is the mark. Here we go. Curved surface area of a cylinder. Here we go. Okay, very important. The curved is only the curved part. All right, which just means the pipe. All right, so that will be this part here. Sorry. Okay. This part, yeah, going all around that, like the back as well. Okay. Curved surface. So what was that? 2 pi RH. That's like 2 pi RH. But be careful. Okay, because we have the base of the cylinder. We have to include the base here because that is on the outside of the shape, not the one at the top. Okay, because that's inside and the surface area is only on the outside, right? So we need to include the area of this circle, and just in case you ever do forget, area of a circle is pi r squared, yeah? So we need to include this. So we put at the bottom circle but not the top. Okay, so that will be 2 pi, the radius is 6, the height is 5, pi radius is 6 squared. Okay, 6 times 5 is 30, and 6 times 6 is 36, we can just write it as 36 pi. Okay, then you do 2 times 30 is 60 pi, plus 36 pi, just like an AX or something. You just add them together, keep the pi the same. So 60 plus 36 is 96 pi. And then we just add the two shapes together, the 72 and the 96. What does that give us? 98 plus 70 is 168, isn't it? 168 pi. Beautiful. Okay. Right, so you get a mark here, you get a mark for this part, get a mark for the circle part, and get a mark for the answer. Show all your working out in case you make any mistakes, then you get all the marks. Okay, or rather, you don't get this mark here. Let me just change that. Sorry, you get the mark for using the formula correctly with the values in it. So again, you don't get your mark there. You get your mark here. Okay, just not just writing down the formula, but putting the correct values in it. Question 17. Need to know your rules of indices, yeah? So, first of all, a fractional index, for example, a to the power of 1 over x. That is the same as a root. And that denominator goes there. Then, of course, the numerator, let's say that is a y, you put that as a power. Or you can put it outside. Okay, so that means 125 to the power of 2/3 is the same as the 3 means cube root 125 and the 2 as a power. You can put it inside as well, but doing the square of 124 is a bit tough. But we know our cube numbers, don't we? 1 cubed is 1, 2 cubed is 8, 3 cubed, 3 times 3 times 3, 27. Study these. 4 cubed, 64. 5 cubed, 125. That's why the cube root of 125 is 5. So that gives us 5 squared, which gives us 25. Straightforward, that one. 25. You see there, 1 mark for writing this. You can put the square inside. That's another way, because 3 times 2/3 is 5 squared. Yeah, that's another way of doing it there. Okay, so basically 1 mark for writing it like this, 1 mark for the answer. Okay, question B. Right, same thing, just remember the minus. All right, when we have a index, it's negative, we can write that as a denominator, and then the moment it goes to denominator, the minus falls away. So we can write this as, let me give some more space, we can write this as 1 over 4 to the power of 5 over 2. Okay, just put it as a denominator, the minus goes away. And then again, it's the same thing, so it's 1 over, the 2 means a square root. Okay, you can put a little 2 there, but that's just not how we usually do things, but you can. Mathematicians is lazy. They sort of like just put a root, it means square root. Okay, but there is technically a 2 there. Okay, and then to the power of 5. Again, we put the 5 inside, but doing the square root of 4 first is easy. Square root of 4 equals 2. 2 to the power of 5. Make my 5 look like a 5. Okay, of course, is 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So that will be 1 over 32. Plus minus, yeah, of course, because when we square root something, plus minus, but it's in block brackets, you don't have to have the plus and the minus. And again, you see, you could have done that the other way around. There are different ways of doing this, but again, basically you get a mark for showing some working out and for the answer. Moving on to question 18. Rationalize the denominator, which means we don't want any roots under the line. So to do that, we multiply it by 1. But anything divided by itself is 1. So root 3 over root 3 is 1. So we multiply a number by 1, we're not actually changing it. Okay. Of course, root 3 times root 3 is the same as root 3 times 3, which is 9, which is 3. So when you multiply a root by itself, they just cancel, and that's 3. and then above the line you'll have 9 times root 3. We can write it like that. Okay, but of course 3 as the fraction is 3, so 9 divided by 3, so that 9 becomes a 3, and the root 3 just hangs around for fun. Okay, root 3, correct answer only. There's nothing else you can write there. Will give you full marks. And just by showing that you're multiplying it by root 3 over 3. Okay, easy 2 marks there. Right, next one. I think they're trying to make this look difficult, but no. Okay, forget about this bit first. Okay, just don't. It's not going to go away. Just get it. Just let's expand the brackets there. Okay, so it's 5 minus root 2, 1 plus 3 root 2. Let's expand the brackets. 5 times 1 is 5. 5 times 3 root 2 is like 3x. 5 times 3x will be 15x. So 5 times 3 root 2 will be positive 15 root 2. Then you can imagine there's a 1. Minus 1 times 1 is minus 1 root 2. Don't have to put that 1 there. But if you do, it's not a problem. It's not wrong. Okay, and then the last one, now let's be careful here. Okay, we got minus 1 root 2 times 3 root 2. Okay, now first, okay, that's not what I wanted. Right, let's try again. Minus 1 times 3 is minus 3. Okay, then root 2 times root 2. Okay, remember, if you multiply root by itself, that would just be 2. So minus 1 is minus 3, root 2 is 2. Now we can multiply them together. That gives us minus 6. Okay. Remember I said there is a 1 there. So well, we can just do this now. 5 minus 6. Let's put some color to this again. Okay, so we got 5 minus 6. It's going to give us minus 1. And then 15 root 2 minus 1 root 2. It's like having 15x minus 1x. That is a positive 14x or 14 root 2. And there we go. Now we can go back to this bit. Okay, we can see they wanted c plus k root 2. Brilliant. So c is, do some colors again. I'm really starting to enjoy this. C is minus 1 and k is 14. Okay, let's see the mark scheme. C minus 1, K 14, B1 for each. Okay, so straightforward. 1 mark each. If you don't get any marks here, you can get a mark there. If you've done 3 out of the 4 correct. Yeah, 3 correct of those. All right. Question 9. Multiplying a fraction with a fraction. It's easy. You multiply the top with the top and the bottom with the bottom. So you can just do the top is 5 times 3 is 15. 8 times b is ab. 6 times a is 6a. And then just simplify it. The a divided by the a will cancel. And then 15 over 6. If you got that, you can divide both by 3. So that will give you 5 over 2. So that will give you 5b over 2. Or, even maybe quicker, you can simplify before you multiply. You can say this a and that a will cancel. Divide this by 3, that becomes 2. Divide this by 3, it becomes 1. So 5 times 1b is 5b. And 2a times, when you cancel this, a 1 equals 2. Either way, that's 5b over 2. Correct answer only. Okay. Right, so you get 2 marks for the correct answer. Nothing else can give you full marks. If you don't get full marks and you have this, you can get a mark there. Okay, or you simplified it there, I guess. Anyway, you got that 2 marks. Now I want to get back to what I want to say earlier. Okay, if I have, what would I have? 2/3 plus, let's say, 1/4. Okay, we need to get the denominator the same. Okay, so one way of doing that will be to multiply the two numerators together, which will give us 12. And then multiplying across, 2 times 4 is 8. See, 8/12 is the same as 2/3. And then multiply the 3 with the 1 will give us plus 3, because 3/12 is the same as 1/4. And then you can just add it and you have the answer. Okay, that's how we can do basic fractions. We call it the smiley face method. So that's what we're going to do every time we do these fractions. Okay, we're going to do the smiley face. We're going to multiply the two the numerators together. 2 times 4 is 8. We're going to multiply bottom right with top left first. Okay, 4 times p is 4p. Then the sign is a plus. And then we're going to do 2 times 3, t is 6t. Okay, that's going to be the first step every time. Okay, just check here now, right? We can simplify things a bit. We can divide everything by 2. Or, longer method, we factorize out a 2 at the top. See, common factor here was 2. 2 times 2p is 4p. 2 times 3t is 6t. And then we can divide this 2 and this also by 2, we get 4. So that will be the final answer. 2p plus 3t over 4. Okay, or a shorter version of this is just, right, like simplifying fractions, we divide the top and the bottom by 2. But if there are 2 terms, you divide everything by 2. That's the secret. Okay. Again, so correct answer only. There is nothing else you can write. We'll give you full marks. Okay. Alright, but yes, if you don't get that, didn't simplify it, you get 1 mark for this whole part and then for the simplified answer. Okay, it has to be in its simplest form because they clearly told you that. Now question C is going to be the same as the previous one. We're going to multiply the two denominators together, okay? But you don't actually have to expand the brackets. You can leave it like that. Now, very important, do bottom right with top left first. So this will be 2 times x plus 1. And then you put the minus. Okay, when you're adding, it doesn't matter if you swap these two around. But when you're subtracting, you need to have bottom right, top left first. Very important. Okay, then you put the minus. Then it's 3 times x minus 2. Get the order here correct or it will be wrong. Okay, now we do need to simplify it, but we can leave the bottom the way it is. You don't have to expand the brackets. 2 times x is 2x. 2 times 1 is 2. Minus 3 times x is minus 3x. And very important, 3 times 2 is 6. And a minus, let's highlight this, a minus and a minus will give you a plus. Plus there, okay. So, to finish this off, right, 2x minus 3x will give us minus 1x, or just minus x. And then 2 plus 6 gives us 8. Okay, and that's correct, full marks, but I usually like to put the positive numbers first. Like, you don't have to have the 1, okay. But I mean, if you write this in the exam, that will give you full marks, okay. Look, correct answer only. Okay, but you can swap the minus. You can have minus x plus 8. That's fine. You can expand the brackets. But okay, if you make a mistake expanding the brackets, then you lose a mark. So you can just leave it like that. Okay. Alright. Look at how the marks is awarded here. Easiest mark is this one. You just need to write those two next to each other. Second mark is expanding the brackets correctly. No, sorry, not expanding the brackets. Writing the next step correctly. And then mark for the full marks there. Okay, going on to question 20. proportion. Y is inversely proportionate to the square root of x. This is what this means. Okay, so when x is 9, y is 2. Alright, now we can take this and write an equation. Y equals, but the moment we put the equal there, that's why that fishy sign is there. It means proportionate. Okay, we need to bring in the constant of proportion. Like, for example, you got a triangle. Okay, one side is 2, the other side is 3, the other side is 4. And then you got a similar triangle, and let's say this is 6, and this is 9, and this is, you can see what happened there? These two triangles are same, but the one has got a scale factor of 3. We multiplied it by 3 each time. That is what we call the constant of proportion. That's what we have here. What is the number I need to multiply this to make it equal? Okay, just like here, this is proportionate to that by 3. Now, inverse proportion just means as the one gets more, the other one gets less. That's the horses eating the hay. The more horses you have, the less days it will take them to eat all the hay. The more horses, the quicker they eat the hay. No, the less time it takes to eat. Yeah, one goes up. Got less horses, got more time that the feed will last them. Right? So here, so we have to put in a k and then have the equation. Okay, the constant. This is the constant that we multiplied. This there it was 3. Okay, we can also write the k. Just you multiply the k. You can put it at the top. Okay, same thing. Okay. Stop licking yourself. All right. So now we got this. We can put these values. We could put the 9 where the x is, and we can put the 2 where the y is. So that means 2 equals k over square root 9. Okay. Then of course square root 9 is 3, and then we need to multiply the 3 there. So the constant here is 6. The scale factor is 6. Okay. Then it says find the value of y when x is 36. So now we can take this equation here, we can write it down, but we know now k is 6. So this gives us the working equation. And then they tell us what is y if x is 36. So that would be y equals 6 over square root 36, which is 6. 6 divided by 6 is 1. Plus minus 1 again because we rooted the 6. Square root, but you don't have to have it. Okay. Look, they want to see the k there. Okay, so to sum up that, they want to see this and then this and then the final answer. Okay, so show you're working out. You have to implement that k. That k just means if you worked out k wrong, then you can get a follow through mark. Okay. Then it says when x is increased by a factor of 4, find the value of y. No. When x is increased by a factor of 4, the value of y changes by a factor of p. Find the value of p. 1 mark. I don't know. What are they doing here? When x is increased by a factor of 4. Let's just see. Okay. So when x was 9, y was 2. So then they bring in the factor. So if x is times by 4, which will make x 36 now, what do we time by y? But we need to find the new y. So let's do this again. Let's make x 36. Oh, they already did. They made it 36. So when x was 36, then y became 1. So what did they multiply it by? Well, it got less. It got smaller. So they divided it by 2. What's the same as dividing by 2? What do you multiply, yeah? If you multiply something by a half, half is 1. So the factor then is a half. So if x gets 4 times bigger, y became a half of what it was. Is that it? Half or equals 0.5, that's the only other one. Does it make sense? I hope so. If not, rewind this and play it really slowly. Okay. So when x was multiplied by 4, it became 36. Then what happened, because we worked it out here, y became half of what it was. That's why it's 1 mark. Right. Question 21. So here we have a cubic graph, because there's a cube in the equation. And let's read all the information carefully. Shows this graph, y equals 3x minus x cubed. The graph crosses the x-axis at A, O, and B. So what do we know about these points? We know actually a lot, right? We know the point A has got an x and a y coordinate, yeah? We know the y coordinate is 0 because it's on the x-axis. So the y is 0. And we know the x must be negative because it's to the left of the center. The point O, of course, is the center, so we know the coordinates there is 0, 0. And B, we know it's going to be a positive x, and also the y coordinate is 0. See, so there's a lot of information just in that one sentence that we already know. The turning points of the graph is P and Q. Alright, we do know also here that Q will have a positive x and y coordinate, and P, of course, will have a negative x and y coordinate. Okay, this is important information that will help us in the future. It says then find the x coordinate, yes, the x, because we already know the y is 0, of A and the x coordinate of B. Give your answer as exact values. Okay, so we already know what to do because we know the y is 0 and there's a y there. So if we make that y 0 and solve it, we can find the x. Easy as that. Yeah, so where the line crosses the y-axis, the y is 0. So we can do 0 equals 3x minus x cubed. Okay, let's make sure your 3 looks like a 3. Oh, man. Come on. Right, what can we do? Well, we can factorize out an x. Take one x from here, put it in front of the bracket, put 3, x times 3 is 3x. And 1x from here, so there'll be 2 left. X times x squared is x cubed. Okay, we can then split this up. We can say x is 0, which gives us that, that point there where it crosses the x-axis. Okay, but I didn't ask for that one. And we can say 3 minus x squared equals 0. Okay. Then I don't like that negative. So if I move the x squared to the other side, it will become positive. Or like add x squared to both sides. Okay, and then we need to get rid of the square. We do that by square rooting the opposite side. And there we go. There's an answer. There's an exact value. It's root 3's exact value. Okay. Of course, we don't have a calculator, so we can't put it in. But that's good enough. But, alright, there are 2 points. There's A and B. Okay, so remember this. Yeah, when you square root something, like we done before in this paper, there's a plus and a minus answer. Let me just go quickly through y again. Let's look at example 5 squared, right? 5 squared is 5 times 5, which is 25. That's why the square root of 25 is 5. But if we square a negative 5, which is minus 5 times minus 5, note that you have to use the brackets, that will also be 25. So that means the square root of 25 can also be negative 5. Same here. Square root of 3 is both positive and negative. So that means x can be square root 3 and x can be negative square root 3. just check which one is which. The A is the one where the x is negative, so the x coordinate here is negative square root 3, and then the B is where the x is positive. That will just be square root 3. Okay, so if we look at the mark scheme, there it is. A is negative 3 or equivalent. I don't know what equivalent. You don't want to. You need to write the root 3. Okay, you can use the quadratic formula there, it seems, but if you have them the wrong way around, I know that or that. So if you have just one, you get 2 marks. Right. So basically, what we go for here, you get 1 mark for factorizing and 1 mark for each correct answer. If they're in the wrong order, you can get. So there's a hair. You can't see the hair. I can see the hair. Right. Moving on to part B, differentiate. Okay. We differentiate to find the equation of a tangent. A tangent, of course, is a line, that's a straight line that touches the graph, and that can give us the gradient. So if we differentiate this, remember, differentiation helps to find the gradient of the line at a specific point. We can put a 1 over here, and we can put a 1 over there. It doesn't change the equation. The 1 is always there, we just don't use it. So we multiply the index with the number in front, so 1 times 3 is 3. And then you subtract 1 from the gradient, which gives us x to the power of 0. Okay, here we do 3 times minus 1 is minus 3. Subtract 1 from the cube, so that will be x squared. Now, of course, anything to the power of 0 is 1, and 1 times 3 is 3. So that will be 3 minus 3x squared. Final answer. Okay. Let's see, 3 minus, okay. And they give you 1 mark for each of these. Okay. Then said find the coordinates of P and Q. Okay, so the coordinates of P and Q. What we know about this point, if we were to draw a tangent there, these are the turning points. The tangent would be a horizontal line where the gradient is 0. And this is what this equation is. Give us the equation of the gradient. And then the gradient will be 0 at the turning points. Okay, so we just need to solve this equation. Alright, so what can we do? Again, I'm going to get rid of the negative by moving the minus 3x squared to the other side, so it becomes a positive 3x squared. Then we can divide this 3, so 3 divided by 3 will be 1. Don't forget the square. And then we square root the 1, but remember there's a positive and a negative answer when we square root something. Square root of 1, of course, is 1, so x is 1 or x is minus 1 equals minus 1. Okay, so let's just check, yeah? Like we said, P is the one where the x is negative, so P must be minus 1, and Q is where the x is positive, so that must be 1. Right, but now we need the y. Yeah, the y. Where is the y on this page? There is a y on this page, yeah? And we want to find out what it is. And luckily we know what the x is, or 2 things the x could be. So we just put the x values we have in there, and then we'll find the y. So that we do that. Right, so y equals 3x minus 3x cubed. Yeah, let's first put the minus 1 in there. So that will be first the 3. And then minus 1 cubed. So 3 times minus 1 is minus 3. Minus 1 cubed is minus 1 times minus 1, which is 1. And then 1 times minus 1 is minus 1. So minus 1 cubed is minus 1. Then minus 3 times minus 1 is plus 3. Yeah, you see? No wonder this is wrong. I put a 3 there. Shouldn't be there. My goodness. Always copy things correctly. There we go. Okay. I'll cut this out. We'll start over. Okay. Right, so we take y equals 3x minus x and put the y value in there, which is minus 1. Minus 1 cubed. Okay, 3 times minus 1 is minus 3. First bit mass, we need to do the cubed, so the minus hangs around. Okay, and of course minus 1 times minus 1 is 1, and then 1 times minus 1 is minus 1. So minus 1 cubed is minus 1. 2 minuses makes a plus, so y is minus 2. Okay, it makes sense. Okay, this is minus 1, and this is minus 2. Okay, it's not to scale. Not to scale that, definitely not. Okay, so that's minus 2. And then we do the same. To find y, we just put 1 in there. So 3 times 1 is 3. 1 times 1 times 1 is 1. There's a minus in front. That gives us y is 2. Nice and symmetrical. Let's look at this question. There we go. Minus 1 and 2. 1 and 2. Right, we got them the wrong way around. You lose 1 mark. Again, you can use the quadratic formula. You can factorize. There are different ways of doing this. So, to sum that up, the marks are given. Setting it equal to 0 gets you 1 mark. Calculating. Right. All right, then manipulating by factorizing or whatever, that gives you 1 mark, and then 1 mark for each correct answer in the right order, in the right place, of course. Moving on to question 22, and we're doing trigonometry without a calculator, and I'm using the ton ratio, so we're gonna have to remember that table that you need to memorize. All right, there are many videos on YouTube showing how to do this, but let me run through you quickly. Right. We want to know the ratios for sin, or the ratio values for sin, cos, and tan. Okay. The angles we're looking at is 0, 30, 45, 60, and 90 degrees. Okay. So let's make, oh, that wasn't nice. Let's make a table out of this. Okay. That's all the values we need to know by heart. Okay, let's change a bit of color here. Okay, so do this. We start by writing down 0, 1, 2, 3, 4. And then we square root all of them. And then we divide everything by 2. And that's it. Now you got your sin values. We just need to clear things up a bit. Square root of 0, of course, is 0, and anything divided by 0 is 0. So the first one will just play 0. Square root of 1, of course, is 1, so we can change that to just a half. Square root of 2, we can leave it like, we can use it like this is. And the last one, square root of 4, of course, is 2. And 2 divided by 2 is 1. Okay. There you got it. Now, for cos, swap it around. Just write everything backwards. Where sin 0 is 0, sin cos 90 is 0. Then after that's a half. The half goes over here. Cos and sin 45 stays the same. We got square root 3 over 2. And then 1. We should just swap it around. Okay, and then for the tan, remember now, tan is sin divided by cos. Okay, so 0 divided by 1 is 0. A half divided by square root 3 over 2. Well, you can remember how to do this. Remember, that means this is a half. And if we divide, we can invert the fraction and then multiply. You can cancel the 2's, we get 1 square root 3. If you want to remember all of that, or you can just remember it's 1 square root 3. Okay, same then, the square root 2 over 2 divided, to divide anything by itself, you get 1. Okay, and then for 60, it's the same 2, just the other way around. So we have square root 3 over 2 divided by a half. But remember, if you want to change this to a times, you just invert the fraction. Okay, cancel that, multiply top with below, you get square root 3 over 1, which is square root 3. Okay, or you can just remember square root 3. Okay, just tattoo it on the inside of your eyelids. And the last one, anything divided by 0, can't, impossible, mass. Okay, so that's non-existent. That's the asymptote. Okay, there's our table. Now we can do the questions. Right, so tons, write down the exact value of tan 60. We have it over there. There we go, root 3. Okay, there, root 3, 1 mark, no arguments. Done. Okay, then it tells us to solve this one between 0 and 360. Okay, so let's see. Let's first move the 1 to the other side, so that will give us 2 sin x equals the minus becomes a 1. Then we divide the 2, so we got sin x equals a half. So we just check here, sin a half, 30 degrees. Okay, so that means sin 30 degrees will be a half. X is 30 degrees. Great, easy. Oh, but why is there another x there? Oh my goodness, they want another answer. Okay, so we need to remember this. If we were to look at the sin graph. Right, so here looking at the sin graph, we saw that this point here, where there we go. Okay, stay there. Okay, at the point 30 and a half, that point there, yeah, 30 degrees, y is a half, right? But there's another point over here, as you can see, that would be the point 150. We will have another half over there, see? So there's another x values. Only those between up to 360, which is over here, where we have that answer. Okay, so this being symmetrical, all we need to do is do 180 minus 30 to get 150. That's the other answer we're looking for. Or you need to remember that to find the sin value, any angle of sin has the same value when you do sin 180 minus that angle. Okay, so that means sin 30 is the same as 180 minus 30, which is sin 150. That's why the other answer we're looking for is 150. All right, so you get marks for rearranging, getting this half, and then 1 mark for each correct answer. Brilliant. Moving on to question 23. Yeah, here we got vectors. All right, we're almost done. Vectors, right, here we go. O is the origin. It's where we start. There's a vector, something moving to the right, we call that A, something going over there is B. Let's see, in the diagram, OA is parallel to BC. So these two lines are parallel. We can put in those little arrows, they are parallel. Okay, which means, okay, let's clear this a bit, which means that BC is also the vector A, but longer. So there might be a number in front. It's twice as long, or 3 times, or 4 times. We can't guess because it's not to scale. But it means vectors, if it's going in the same direction, if the lines are parallel, it's the same vector. Although we can see that that one vector, the magnitude is more. Okay. Oh, and then they tell us BC is 3 times OA, so that means it's the same vector but 3 times. So this is going in that direction. 3A. So we got the vector for BC. That's 3A. The position vector of A is A. Okay, position vectors means it starts from 0. Okay, is A. Yeah, we can see that. We already saw that. And from B is lowercase b. Oh, we got it. Find the position vector of M. So what they are asking us to find is this. Going from the origin to M. Okay. Of course, we don't know what that is. We're going to have to follow a path. Well, we do know. So let's try a different path. Okay, let's go like this. Okay, from O to A is A. So I'll put it, yeah. So OM is going to be OA, which we now know is lowercase, plus AM. Oh, okay, damn. Again, we don't have AM. That's a problem. Okay, hey, let's try to find that. All right. Gonna switch colors again. Let's see if we can find AC. Don't know what AC is, so we're gonna follow a path that we do know. So AC would be AO plus OB, and then this one, BC. That's what vectors is, right? Doesn't matter what path you follow, you should end up with the same vector. So AC going from there to there, yeah. So it's just you end up in the same place. It's the same vector. That's how special vectors is, right? So imagine you need to get from A to B. Doesn't matter how, you have the same vector. All right, so let's do that. So from OA is A, but in the opposite direction. We're going against the arrow, so that's negative. Remember that. We're going the wrong opposite, up the one way. We are negative, right? Then OB, we're going with the arrow, so that will be B. And then from BC, we knew that's 3A. Okay, and then we can simplify this. 3A minus A, that gives us 2A plus B. Great, so we know this is 2A plus B. All right, I got now all the information I need. So, to find OM, remember, we're going to do OA, which we say is A, and we're going to add AM. Okay, now we know AC is 2A plus B. They told us M is the midpoint, so this would just be half of that. So we just need to divide this by 2. Okay, so what does that mean? Well, there are different ways to write this, but we have to half the 2A. 2 divided by 1, so that would just be A, and then 1 divided by 2 is half B. No, not 1 over B, half B. You got that? We've taken 2A plus B, we half it. Half of 2A is A, half of B is half of B. Alright, easy as that. So A plus A is 2A plus half B. Meaning another way to get from A is going A, another A, and then half a B up. Sounds like it could be possible. 2A plus half B. Let's see what the mark scheme says. 2A plus half B, final answer. I'm sure if you wrote 0.5 it would be fine. Okay. Right, so the thing is, you can get a mark for just writing this. So even if you don't know what to do, you're confused, you write that, you get a mark for it. Okay, get a mark for this, 2A plus B, and then mark for that. You genius. Right, question 24. Only 5 marks for the last question. Easy as pie. All right. The line y equals 7x plus 3 intersects the curve. Okay, so of course this is a straight line. and this is a parabola at the points A and B. Okay, now if you're in the exam and you got Desmos, you can just put those things in there and they'll give you the answer. So let's do that. Right, so here is the line y equals 7x plus 3. There is the parabola, quadratic graph of y equals x squared plus 5x minus 12. And then it says they cross at 2 points. So you see they will cross down there at minus 3, minus 18. And they will cross up here at 5, 3. Good, good, we got the answer. Question done. Okay, but of course, in the exam, you don't have this, all right? It's 538, what we're looking for. You don't have this. So how we do this without a graph? That's the question. Okay. How do you do this? Well, at these points where they cross, they are equal, right? The y value for both of them here is the same, yeah? It's both going to be minus 18. It's only at this point. Anywhere else, they don't cross, they're not the same. The same here. Here, they got the same x and y values. All right, so it means they are the same. So it means to solve this, we can set them equal to each other, because if the a is minus 18 and the y is minus 18, this equals that. All right, so we can write x squared plus 5x minus 12 equals 7x plus 3, because at the points where they cross, their y values are the same. That means their x equations would be the same. We just set them equal to each other. And then we solve this. Okay, so we do x squared. I'm going to leave the 5x there. Subtract 7x, or move the 7x there. So we subtract the 7x. We got the minus 12. And we got the plus 3 becomes minus 3. And there's nothing left to the right, so we put a 0. Simplify it. X squared 5x minus 7x is minus. It's negative 2x and 15. Okay. Right. Now we need to solve this. There are different ways of doing this. You can do trial and error. It's not good. You can do factorization, or you can use the quadratic formula. I'm going to do factorization. Let's try that. Let's try to factorize it, see if it works. Okay. So I'm going to put the x and the x here, because x times x is x squared. Now we need to think of two numbers we multiply together to give us 15. Okay, that could be a 1 times 15. That could be 3 times 5. That's about it. Okay. Now, we don't have a 15, we've got a minus 15. Okay. And when we add this together, we want to get a minus 2. So we're not going to get to a 2 with a 1 and a 15. So I'm saying this 3 times 5 is where our answer lies. But to get a negative 15, one of them has to be negative. Okay. Now minus 3 plus 5. That of course is 2. That's not going to work. But 3 minus 5, or 3 plus minus 5, doesn't matter, is minus 2. That's what we're looking for. We want a minus 2 when we add it, and we want a minus 15 when we multiply. So that will be plus 3 and minus 5. Let's just double check if that's correct, yeah? X times x is x squared, good. X times minus 5 is minus 5x. 3 times x is 3x. Together, that gives us minus 2x, brilliant. And 3 times minus 15. That works, okay. Great. So now we know we factorize it correctly. Right, so next thing is just to solve this, and we set each bracket equal to 0. And then we get x, move the 3 there, is minus 3, move the 5, x is 5. Okay. Now they say A and B, they don't say which one is first, so I guess this time the order doesn't matter, but we'll check the mark scheme in a moment. Okay, so this is like I've shown you. Look, there we got the 5. And we got the minus 3. Now we need to find the minus 18 and 38 without the graph. Okay, what is it there? We found the x coordinates. Now we need to find the y coordinates. Where is it? Well, there's two of them. There's one there. There's one there. Okay, of course, this one is easier. Doing y equals 7x plus 3. Right, so all we need to do is put the x value in there. So y is 7 times minus 3 plus 3. That will give us minus 21 plus 3. Yes, that's what it was, wasn't it? Minus 18. So that's minus 18. And we do the same with this one. We take that equation, put the 5 there. So it's 7 times 5 plus 3. That will give us 35 plus 3. And that was the right answer, remember? Now what about the other equation here? Well, you should get the same answer if you put it in there. So this will be a good way if you have the time. I mean, it's the last question. You got till 10 minutes, 5 minutes to waste in the exam. If you put the values in there, you should get the same answer. And that's a way to check if you got the right answer, all right? So let's just do that. Let's put the minus 3. Let's do that quickly, just for fun, into this equation. And if we don't get the same answer, well, then we're wrong. But I recommend only doing this if you have the time, because it doesn't count marks. Minus 3 times minus 3 is 9. 5 times minus 3 is minus 15. Minus 12. That will be minus 27. Yep, that's minus 18, so we know it's correct. Okay, and the same if you put the 7 in there. Let's do that quickly. That will be 49, 35, 12. Well, what is it? So 35 minus 12 is 23. 49 plus 23 is not 38. Oh, because I've done it wrong, of course. It's 5. Why do I put a 7 in there? Put a 5 in there. Silly. 5 squared is 25. 5 times 5 is 25. That's 50 minus 38. Yep. That's what we were looking for. Got it right. If you got the mark scheme, you just check the mark scheme. 538 minus 3. Right. It doesn't matter which order this is. It doesn't say it, but alright, it could be in any order. See, you can use the quadratic formula as well. You can substitute the one equation into the other one. Okay, so basically it's 5 marks here for a correct method, minus setting them equal to each other. Okay. Then for your algebraic work, and then you get 1 mark for each x value, and then you get 1 mark for the y values. That's the way I understand the mark scheme anyway, to get your 5 marks. And that's it. Then you're done. You finished your exam. You feel great because you're gonna get an A star. Go home and be happy. Thank you. Bye-bye.